So I'll explain what are the things we'll start with this initial session, and then we will gradually progress on towards the hands-on and show you the different tools and technologies that we have in Azure to work with the data engineering profile. Now, since we're pretty new to Azure, before we start with the hands-on and give you more background about the data engineering, let me actually talk a little bit about the cloud computing environment. So when we look into the cloud computing, what is cloud computing essentially? So simply put, if you think from a very holistic perspective, cloud computing is a space which is nothing but a portal. So if you're working in Azure, if you're working in AWS, that is Amazon Web Services, or if you're working in Google Cloud Platform or GCP, these are the three major CSPs. We call them CSP, nothing but cloud service providers. They have a portal where essentially you log in and you start your development. So couple of advantages that comes with any cloud service provider is that you don't need an initial cost. So you don't need to own any hardware. You don't need to set up any software. There are no licensing costs involved. You can start with day one. And also there is no initial capital expenses, because you don't need to buy any hardware. You can just rent it and you can start with a pay-as-you-go model. Now, a couple of important terminologies or concept we should remember in the cloud computing environment whenever we're working. So if you look into the cloud model, how do we set up our environment? There are essentially three models that we have in the cloud computing. The first is called as a public cloud, then we have the private cloud, and then we have the hybrid cloud. Now, how do they differ? Public cloud, which is the most common thing that you're going to use, is something like this, where if you buy a service from any of the CSP, since we are focusing on Azure, I'll take most of the examples from Azure. Let's think of an example that I want to create a SQL database on Azure. So think of it from an on-premises perspective. Whenever we create a SQL server, I need to buy a hardware. So I need a physical machine where I will have processor, I will have RAM, I'll have hard disk, and I'll have SQL server. So I need to buy the license of SQL server and install it. So I need to get so many costs beforehand. In case of Azure, when I create an Azure SQL database, I just log into the Azure portal. I quickly create my configuration and I create a SQL database. Now, when this gets created, Microsoft, being a CSP, has to create this physical SQL server in some of their data centers. So Microsoft, being a very large organization, they have currently around 32 data centers around the world, if I'm not wrong, and it's increasing every day. So they create a data set, they create an instance of your SQL database in one of their physical data center that you can choose where you want to host this physical database. Now, when they created the hardware where this physical SQL server is created, you as a customer don't own that hardware. So this hardware is essentially shared across multiple vendors. So think of it like this. If I am a user who's creating a SQL database in, let's say, that East US region, there is one more user who's creating another SQL database in East US region. Microsoft might create this SQL server or this physical database in the same hardware rack, but do not worry. The data is never shared across the vendors. It's only the hardware which is shared across the vendors. So here the cost obviously becomes less because you are essentially sharing the hardware between vendors. So this is a concept of public cloud where the hardware is shared across multiple vendors. Then we have the concept of private cloud. So this is a typical example which is mostly used by government organizations where they don't want to share even their hardware. So what happens is that if you create the same SQL database in a private cloud, then you essentially own the hardware. I won't say own. It's something like it won't be shared across multiple vendors. So it will be exclusive to you. That is the concept of a private cloud. Then we have the hybrid cloud. So in the hybrid cloud, what happens is some of your infrastructure will be on premises, that will be within your network, and some of the infrastructure will be on the cloud space. This is a concept of hybrid cloud. So these are the three different technologies or the design choice that we have in a cloud environment. Now, another important aspect in cloud is the technology or the tools itself, how they are created. So when you work in cloud computing, you'll hear these three terms very often: infrastructure as a service, platform as a service, and software as a service. So these are the three essential categories on which we create any resource in a cloud factory. How it happens is that if you think about platform as a service, which is the most common thing that we have, when I say most common, is that something that is very popular where people create so many PaaS resources or platform as a service. What does this mean is that when you create any resource in Azure or any other CSP, you don't need to bother about the underlying hardware how the hardware is managed, how the connectivity is set up. Obviously you have to set up the networking, but the hardware is completely managed by the CSP. Then the software upgradation, the patching, all these things are also managed by the CSP. So again, if I think of an example of SQL database, if you create an Azure SQL database, which is a PaaS offering, I can quickly spin up my SQL database. I can set up the configuration. I can give the details, how many cores we want, memory we want to consume, how much IOPS we need, and we can quickly set it up. Microsoft, being a CSP for Azure, they have an SLA that you will get this much of minimum performance, this much of uptime. All these things are part of Microsoft's SLA. Also, the upgradation and the scheduling and the patching is done by Microsoft. It's taken care by them. You don't have to bother about these things. That's the concept of PaaS, or platform as a service. Then we have infrastructure as a service, or we call it as IaaS. What happens in this case is, here you want to work in a cloud environment, but you want to manage your own infrastructure. So a typical example would be a virtual machine. So if you create an Azure virtual machine, there you manage your operating system, you manage your software. So for an example, you create a Windows virtual machine. Inside you install SQL Server. So Microsoft will give you an image of a virtual machine along with SQL Server installed, but you are responsible for the OS upgradation, the SQL Server upgradation, the patching. All these things are done by you. This is an example of infrastructure as a service. And then finally, you have software as a service, where some people will also call it as a serverless architecture. What happens in this case is, you're utilizing the power of cloud, but the software that you're using, it's actually coming as a product. So a simple example would be Office 365, or now Microsoft has renamed it to Microsoft 365, where your underlying server, where the mail exchange is happening, that's happening from a cloud perspective, but you're actually using that product to create your own set of products. So this is a very high level concept of cloud computing. How do we work with cloud, and what are the different concepts we should keep in mind before we start our journey in cloud? From a work perspective, it's very simple. You just log into the Azure portal. So this is a simple example. I've opened the Azure portal. So this is how it typically looks like. You log into portal.azure.com. I'm not going to go through so many hands-on today because it's the first session. Just wanted to give you a physical overview. You have to create your subscription, and then you can get started. Now, people who don't have an Azure subscription, like for an example, I have a Microsoft Developer Network subscription. So people who don't have a subscription, Microsoft gives you a 30-day free subscription for Azure, and you get $200 of credit, and you can create your resources inside the Azure portal. So you can just create a free subscription with your email ID. You get $200 of credit, and you can start your journey in that. I'll definitely share some of the tips with you to save money so that you don't exhaust your $200. Otherwise, it will be difficult. You cannot work. If I'm not wrong, just a quick tip. Microsoft do asks for a credit card information. That's just for verification. They will not charge you. If you exhaust your $200, they will not charge you extra. You will receive an email that your subscription has been disabled. If you want, you can pay and you can restart your services. So don't worry about the credit card information. You can keep it, you can save it. They will not charge you from your credit card. So that's a very quick overview of cloud computing and the Azure portal. Now we will dig deep into the data engineering role and how Microsoft has stacked up the data engineering portfolio in Azure. Now, before I do that, I'll take a quick pause to check with all of you. Do you have any questions till now?
No.
Seems like no questions. Thank you. So let's get introduced into the data engineering world. Now, since we are talking about data engineering, of course, the core of data engineering is data. Now, it's no secret that the data that we use and we consume has been growing more and more in size. So it's a very old cliched line, is that all data is the new oil. So I'm not going to go through all the things. We all understand the importance of data now. So what's happening is nowadays, whenever we're looking into the world and we're seeing the projects, we're doing the work, we see that the data volume is increasing significantly. Now, since the data volume is increasing significantly, we have to use some kind of new technologies. We cannot use the traditional mechanism of dealing with data because we are not getting the performance that we expect, and we are not getting the outcome that we require. So with the increase of new data and the increase of data, we are seeing a lot of new technologies, new roles, and new approaches which are being affected by the data professionals. Okay, so what happens in this case? How do we change our life? How do we generate value for anyone so that whenever you need to analyze some data, how do you get the analysis out? How do you get the information out of the data and explain it to the stakeholders? That's something that we're seeing very often, and based on that we are seeing a lot of change in the role. Data abundance. So it's again, we have seen that the data is now increasing in size, and not just that, the sources of data, they are also changing day over day, and day in and day out. So if you think of like 10-15 years back, we would have limited set of sources. We would have SFTP, flat files, databases, and all these things. These were very common, so we would use them as a source, and then we would process the data, perform an ETL job, create an analysis services model, and show it in a report. That was a simple thing that we had, and we used to call it as BI or business intelligence. But in today's world, when we have so many different varieties of data, we get data from different sources. Think of it the IoT systems. So if you have an Internet of Things connected systems, there are so many sensors which are generating the data. If you have a smart bulb in your home which is connected to the internet, that is generating data at a huge scale at every second, and that's a different type of data which we didn't have a concept 10 years back. So the sources of data is changing rapidly, and the format of data is also changing rapidly. Another example is if you do any kind of no structured data. So I'll come to the no structured data. I'm just saying that if you want to do any kind of audio analysis, if you want to do any kind of video analysis, all these things were not possible to do in 10-15 years back. So now you see that you have so many smart devices connected to the source, connected in your home. They are generating data, they have to process the data. So these things are changing rapidly. So the landscape of data is changing so much that the data is becoming huge in size. Now, if we talk about the format of the data, there can be different format of the data. We can have still structured data, which we can use in the typical SQL database or a SQL data warehouse, or we can have unstructured data, which are this new type of data that we have. For that also we have different tools and technologies in Azure. Not just that, not just the storage and the variety of data. When we deal with any kind of data, we have to keep in mind different things. So if you're working in a organization, or if you're working in a project where the client or the project is from a specific region, you have to maintain the GDPR or the General Data Protection Rule and all the other different standards. This is very important when we are dealing with data. I'm pretty sure that all of you have experienced this, is that there are so many classification of data that we have, and you cannot get the data out of the specific region, you cannot store it in a different format. If you store it in a different format, you have to do encryption. So there are different rules that we have to set up in the data. So we just don't deal with data from different format or different volume. When we store the data, we have to keep these things in mind as well. Another concept is the language. So it's not always that we will store the data in a specific language. We can store the data, or we have to store the data in different languages as well. When I say language, I'm talking about English and other spoken languages. That's something also we have to keep in mind. Then we have the different format and the visualization. So it's not always that we will have only one visualization. Like, I'm not gonna be able to only show my reports in Power BI. There can be scenario where I might have to create a report which can be visualized in maybe Tableau, maybe ClickView, or maybe a simple Excel report. So we have to analyze our data and create a data set which could be easily served and feed to the specific visualization tool. Because at the end of the day, whenever we deal with any kind of data, the final layer or the final stage of my data is the visualization, where we actually get the information out of my. Keeping all these things in mind, Microsoft continuously releases new technologies to the Azure platform, and whenever you work in that, we have different things to play with. Okay, so this is a simple concept of data. Now, when we think about the data, again, since we are moving to cloud, first and foremost, we have to understand how we previously had to work with the data and what advantages does cloud bring into us. Why we are actually moving to the cloud? Why there is a sudden, shift in moving to the cloud environment. Let's understand the difference between on-premises and cloud-based servers. So typically, whenever we have previously worked on, we have been working on the on-premises infrastructure. And now that we have seen that a lot of clients are moving towards the digital and they are moving to the cloud space. Now let's look into first what are the on-premises environment we have. So first and foremost, when we talk about the on-premises environment, we have the computing environment. So what is a computing environment? Computing environment is nothing but you buy your physical hardware. So you have to buy your servers, your network infrastructure, and your storage. Now, to have all these things working in tandem, you have to have a power, you have to have cooling, you have to have periodic maintenance, and the most important thing is that the upgradation. So you know that whenever Microsoft releases a product, maybe it's an OS, maybe it's a server, maybe it's a database, all of them have an end of life cycle. So if I'm not wrong, currently from a SQL Server perspective, if you don't have a long-term licensing, Microsoft does not support SQL Server 2008 or 2008 R2. So all the products that Microsoft has, they have an end of life cycle. Is there a question? Okay. So you have to maintain your upgradation log available. Like whenever a product is coming to the end of life cycle, you have to upgrade your product. So these things are always there whenever you're working in an on-premises environment. Then we have the cost of licensing, not just the operating system. Whenever you buy a physical hardware, you of course need an operating system. So this OS will have a cost associated with it. On top of that, if you buy any software, the softwares are also have a licensing. Now, this is a specific type. I'm pretty sure all of you know about this, the client access license. So what happens is that if you go for a CAL is something where Microsoft or any other vendor gives you a preferential rate. If you buy, a bulk product, so you get a preferential licensing rate, which Microsoft calls as CAL or client access license. And as companies grow, licensing arrangements become more restrictive. Then we have the maintenance. This is again one of the pain areas that we have seen. If you have your own software and you run your devices, you have to maintain them so that they don't clog up and they don't fail. And this not just includes your hardware. You have to update your firmware, drivers, BIOS, OS, your software, antivirus. All these things are required for you to maintain. So these things are also part of your regular maintenance. Then we have the two most pain areas, the scalability and availability. Now think of it like this. This is something, guys, I'm saying from my personal experience. So when in a traditional on-premises environment, when we create a physical environment for any of the customers, let's give something that we have faced. So it was quite a years back. So we designed a solution, and for that we had to go for a SQL Server. Now I'm talking about a time when SQL Server was not at all available on Linux or Unix system. It was only available on Windows Server. So if I'm not wrong, it was 2005 or 2008 R2. It was pretty old. So based on several discussions with the client, how much data they're expecting, how much will be the transaction rate, all these things we discussed, and we came to the conclusion that since we're going for a SQL Server, of course we need to have a Windows Server with us. So we decided that we'll go for a Windows Server, where we'll have a Xeon processor with, I don't remember exact configuration, but it was something like we would have 16 cores and we would have a co-processor. And along with that, we will have a SQL Server. So that SQL Server will have 90% memory allocated. And we had 128 GB of RAM in that. And we had somewhere around 68 to 128 IOPS. So we went for that configuration. Now what happens is that in a typical project, your data sizes increases over time. So after 3 to 5 years, this client was actually having memory bottlenecks. So what do you have to do? If you have memory bottlenecks, you of course have to increase your hardware. So the same thing needed to be done there. So they had to increase their RAM, they had to increase their storage, and all these things require a bit of time. So in a typical, organization, it's not that you're choking on your memory. You just swap the hard disk and you increase the disk space, or you just swap the RAM and you increase the RAM. There are a lot of things that needs to be done. Based on that, they can take a decision and they can increase their hardware. So scalability is a very painful area in an on-premises world, where if you're choking for memory, it's not just always that you need to upgrade. There are scales where you need to maybe downscale also. Maybe you're not utilizing that. For example would be a dev system or a QA system where you don't need to go for such a high volume of data transfer. It will not happen. So you might have to downscale there. Now what happens is, again, think of it from a licensing cost. Since we don't need that much power in SQL Server, so I cannot, any customer cannot go and buy different versions of SQL Server licenses. So maybe they want to say that, okay, for my dev and my QA system, I'll go for a SQL Server Developer Edition, or for my production, I'll go for a SQL Server Enterprise. Now that your cost increases significantly because you're buying different licenses. So what typically clients used to do is that they'll buy a bulk of SQL Server Enterprise license and they'll create separate instances for different environment. So this is a very pain area in scalability. So this is the same thing that we have in here. Also, we talk about availability. Availability is one of the most important concept in any infrastructure. What is the availability of your system? Now, typically we need 100% availability, but that's not possible. So any product or any project that you see, all the clients will have an SLA of 99.99 or 99.999%. So this is how it actually works. So if you work in the Azure SLA also, Microsoft will give you an SLA of 99.995%. So if you consider into an hours, so this will be 8,760 hours a year. Microsoft also supports. Now, for an on-premises server, the more uptime for the SLA requires, the higher the cost. Then we have support. So what is the support? So think of it like this. You're creating your physical data center. Now you say that I want to get all my products from Dell, or I want to get all my products from HP, or you want to say that I will create my own data center. So how will you get the support? If you buy everything from Dell or if you buy everything from HP, initially if you buy a hardware, they will give you a free support for 2, 3 years or 5 years. But of course, you cannot get away with all of your physical hardware after 5 years and create a new system. That will increase the cost multifold. So after 5 years, you again have to buy or renew your support licensing with the specific vendor. That's something, again, a cost that we have to keep in mind. Multilingual support is something that we have in not just on-premises SQL Server. We have to include this in our cloud journey as well. So in on-premises, what happens is multilingual support is something that we decide on the basis of our collation level on the SQL Server. So if you have a non-English speaking data or a user set, then we have to keep this in mind that we have to have multiple servers because one database can have only one collation. That's also something we have to keep in mind. And finally, we come to the TCO, or the total cost of ownership. So in terms of TCO, or the total cost of ownership, we have to keep all these things in mind: the hardware, the software licensing, the labor, that means the installation, upgrade and maintenance, and the data center overhead, where you have to include your power consumption, your telecommunication, building cost, your heating cost, your cooling cost. So this is something that becomes pretty exhaustive when you think about the actual usage. So this is something that we call as capex, or capital expenditure. Now again, I'm going a bit into this because this is something that is required when we deal with our solutioning, like how should we create it, because smaller organization like startups and all, it's very difficult to go for this kind of capex, because this is something that you have to keep upfront before you start your business. On top of it, we have opex, which is the operational expenditure, which is continuous part of your project or your organization. So these are some of the costs that we have in an on-premises system. Now, if we have to consider the same cost from a cloud perspective, what benefits do we have? When we think about the cloud environment, the compute environment. So in this case, first and foremost, we completely eliminate the concept of capex. Since cloud environment is completely virtualized, we don't have to bother about any kind of physical or logical hardware, because these are all logical infrastructure. So if you want, you can just say that I want to create a virtual machine where I want to have this much of RAM and all these things, and it's a pay-as-you-go model. Microsoft will not say that, okay, give me the upfront licensing for your OS, give me the upfront licensing for your SQL Server. They will create a bundled product for you, and it's a pay-as-you-go model. So Microsoft will say that if you use this for 1 hour, we're going to charge you this much. If you use it for 1 day, we're going to charge you this much. So there is no capex involved in a computing environment. Okay, so this is very, very important and very flexible in terms of capital expenditure. Now, I'm not going to too much of these details. I'm going to share this document. You can see this and read through this. it talks about different Azure services. I'm not going to talk about the Azure services now. I'm going to talk about them a little later. What is a blob storage and what is a disk storage. Maintenance. Again, since you don't own any physical hardware, you don't have to bother about the maintenance. It's completely part of the CSP. So Microsoft will manage your physical hardware, your networking, your firewalls, your network security, fault tolerant, compliance, physical security. All these things are managed by Microsoft. You don't have to worry about any of the administrative jobs. All the GDPRs, the policies. Of course, you as a user have the flexibility to create your own policy, but the GDPR policies, the physical data center, so the cooling and the networking. When I say networking, I mean to say the internet. All these things are part of your cost. You don't have to pay anything extra for that. Scalability. This is by far the most important concept in cloud computing is scalability. The problem that we talked about in a typical on-premises scalability is a piece of cake in cloud. When we work with the hands-on, you will see that the same problem that I explained in the physical SQL server. If I am choking for memory, if I'm short of hard disk space, it's just a click of a button in cloud. You can just click and you can quickly upscale. If you feel that, okay, I don't need this much of memory, I don't need this much of space, you can again click a button and you can downscale. So it's very, very simple in the cloud infrastructure, the scalability. And then availability. Of course, since it is backed up by Microsoft, Microsoft has SLA for all of their products. So the minimum SLA that you're going to see for any Azure product is 99.99%. There are some products which has more than that as well. So you don't have to bother about your availability. Okay, another thing I should mention about availability is that this is a very good concept, and this is a practical thing that we have seen in our day-to-day lives also. 2-3 years back, there was a physical outage in one of Microsoft's data centers. It was, if I'm not wrong, it was in Florida or somewhere, where there was an earthquake fire in one of their data centers. So a lot of Azure resources went down. Now, this is a very practical scenario, because physical calamities or natural calamities nobody can predict and nobody can prevent. So there was a fire, there was an earthquake, and there was a fire in Microsoft's data center. So a lot of Azure services went down. But when I say went down, I mean to say that still these products were available, but they had a limited resources. It was a bit slow. But think of it that if this happens in a physical data center, if you have a physical data center, if you own that physical data center, I sincerely hope not, but if something happens in that, if your data center is gone, all of your data is gone. Or you have to physically manage a backup of that data, so the cost again increase. Then how did Microsoft manage this? So what happens is, folks, please keep this in mind. Whenever you create any resource on Azure, I'm again going to revisit this topic, just an introduction here. Microsoft makes backup of your data and they store it in different physical data centers. That is also part of your cost of the product that you buy from Microsoft. But Microsoft does not disclose this backup to you. It's managed by Microsoft. Why Microsoft does is that Microsoft has a SLA of 99.99%. Now, in this case, if there is a physical fire in the data center, how does Microsoft maintain the SLA? So part of their SLA, they always take a backup of your resource. It's just that it's managed internally by Microsoft so that they can maintain the SLA. So your availability is again taken care in cloud. And then finally, we have support for anything that you do. If you're facing any issues, you can reach out to Microsoft. You can create a support ticket and you have somebody to point to whenever there is an issue, and also the multilingual support. So the total cost of ownership in this case is very, very less compared to your traditional on-premises system. You can just buy an Azure subscription. Based on that, what all products you need, you can just create these products and you can get started with a pay-as-you-go model. If you need to increase your stack, if you need to upscale, you can do that. If you don't need, you can downscale. Another important concept is that in Azure, you can even pause your systems. So think of it from an ETL perspective, that you have a data warehouse. Now this data warehouse, of course, in a data warehouse, we have a latency. So maybe this data warehouse runs a job and populates the data every day. So out of 24 hours, this data warehouse will be operational for, maybe 6 hours or 8 hours. So if you buy a SQL server, you have already paid everything. But in case of Azure, you can even pause this data warehouse so that you can save a lot of money. These things are also possible in Azure. Finally, we have the lift and shift. So the lift and shift, I'm gonna just explain a bit because we're gonna have a hands-on with this one. Very common term you're gonna hear in the Azure world is lift and shift. Lift and shift is nothing but moving or migrating your on-premises to Azure. So there are a lot of tools which are available from Microsoft and third-party tools to help you with this lift and shift. So think of it that you have a physical machine from where you want to move to a virtual machine. So if you want to migrate from a physical machine to a virtual machine, we call it as a lift and shift. Now, of course, there are certain prerequisites that we have to keep in mind. Another example would be if you have a traditional SQL server, from a traditional on-premises SQL server, you want to move to a Azure SQL. So you can perform a lift and shift because you don't want to lose your existing data. You don't want to lose your existing application which you're using. You just want to switch it when you move to Azure. So there are different ways that we can do it. There are different tools and support available from Microsoft where we can quickly move from our on-premises system and move to cloud. So this is called as lift and shift. Okay, so this is something from a cloud perspective. Again, a little background about cloud. Now we will slowly move into the data engineering world and we will talk about different types of data. So the next couple of things that we have is all about data. Now before I move into data, and I'll again take a quick pause to check if you have any questions.
We are good, sir.
Okay, no worries. Thank you. So now let's talk about the data types. Again, it will be a bit of a refresher for most of you. So what are the different data types that we have? So typically when we work in a data engineering world, we have, I won't say two, this is a bit wrong. We have three types of data. One is a structured data, then we have the semi-structured data, and then we have the no structured data. So what is a structured data? Structured data we have all seen where it's essentially nothing but a two-dimensional model where we have a table. So in that table, we have a row and we have columns. Each column will have a row associated to it. Typical example is a SQL server, SQL database, a CSV file, all these things we call as a structured data, where we have all the data stored in a table. So before we create a system, we have to create a structure of the data. Now how the data is going to look, so we have to create a structure or the schema beforehand. And if you're working in a relational database system, then how do we store our data and how do we create the relationship between them? So this is something that we call as a structured data. Now when we talk about semi-structured data and non-structured data, in semi-structured data we do have a structure but it's not fixed. So for an example, a JSON file. So in a JSON file, you will have a value and a pair. So you will have the key and under that you will have values. So they do have a structure to follow, but it's not fixed. So for an example, if I have to create a comparison between a structured data and a semi-structured data, how would I compare is, if you create a table, now let's take an example that there is a customer, so his customer ID is 1, and if I think from an address perspective, maybe this customer has 2 address, so he owns or she owns 2 houses. So how do we store it in a structured table? We cannot have 2 entries for the same record. So what we have to do is we have to create a different approach where we can have one row specifying address 1, another row specifying address 2. Now that creates a lot of problems. So whenever we create a typical RDBMS, we have to think about the uniqueness of the data, the key concept and all these things. So we cannot have duplicates. So how do we set up all these things? So that creates a problem. But in case of a semi-structured or a no structured data, it's pretty easy. The reason is that since they store the data in a key value pair, so we can have one key, under that we can have multiple value. So we can say that my customer ID is 1, I have address 1 this, and another tag I will have address 2. So that's pretty easy to store in a no structured data. Now in a traditional SQL based world, we typically use TSQL or transact structure query language, which we use to interact with our data as a query language. But in case of semi-structured data, we typically store the data in Cosmos DB or HBase or any other storage, and we use something that we call as NoSQL. Feedback, folks. NoSQL is something that stands for not just SQL. There are a lot of NoSQL data stores which also has support for SQL. Now there are all, of course, a lot of benefits of storing your data in a semi-structured or in a no structured way. You don't have to create a relationship beforehand. You can store the data in a raw format. All these things are there. Since we don't have to create a relationship beforehand, so we save a lot of time in the data modeling. And typically we use NoSQL when we are dealing with a big data set, because relational systems are not designed to handle very high volume of data. And what is an exact non-structured data? These are something which doesn't have any data. Microsoft typically calls it as free flow text. When you work in Azure environment, you will hear that Microsoft calls no structured data as free flow text. That means that it doesn't have any shape, any size, any format. Think of an audio file. Think of a video file. Of course, they have a format. I mean, maybe an MP3 or an MP4, but they don't have a structure. But still, we can analyze. We can do audio analysis. We can do video analysis, and all these things. Now, when we store, NoSQL, there are typically four types of NoSQL storage that we have. Again, we'll have demo on all of them. Key value store, where we store the data in a key value pair in a tabular structure. A typical example would be your JSON. Then we have document database, where all of these JSON files are stored in a native format. So there is no transformation, there is no relationship. It's just EL, extract and load. A typical example would be Azure Cosmos DB. Then we have graph database. So this is a very specific and a niche database that we have, where the data is stored in a graphical format. So I'll give you an example. What is a graph database? Think of it like this. Whenever we go for a graph database, we'll go for a graph database when we have a self-reference data store. This is something, think of it like this, that maybe there is a school. So in that school, there is a principal, then there are different teachers in that school. So there is science teacher, there is maths teacher, and all these different teachers. Now principal is the top, so the science teacher reports to the principal. The maths teacher also reports to the principal. Now then there are different labs, so there are different lab attendants. So one lab attendant reports to math teacher. Maybe that same lab attendant reports to the physics teacher as well. And whenever the performance cycle comes, the performance is completely done by the principal. So you can see that there are a lot of self-reference and there are relationals which are repeated. So whenever you have this kind of things, then we go for a graph database. Now, if you look for graph database, Neo4j is by far the biggest graph database that we have. But Microsoft has enabled support for graph database also inside SQL. Very basic level, but it's still available. And then we have column database, which we call as column store or column based databases, where the data is stored in a columnar fashion. I'm not going to go too much of detail about the columnar data store. When we move to different storages in Azure, I'm going to show you a demo on that, and I will. So these are the typical storages that we have when we think about the data type. Now we will move details in Azure. Now we see that we have data coming in different format: structured, semi-structured, and no structured. Now since we're working on Azure, what is the storage that we're going to use and in which use case we're going to use these storages? Okay, so let's think about the Azure storages. Azure storage or storage is an essential concept in any project or application that you work. Anything that you do, you need to store your. Now Azure storage is something that we call as a storage account. A storage account is essentially a one-stop shop where you can have four types of stores. Now you can use these four types of store, or you can use only one type of store, but you have to create a storage account. Once you create a storage account, Microsoft will provision these four types of storage. Azure Blob. Blob stands for binary large object. As the name suggests, here you can store any type of data. It doesn't require shape, size, format, anything. It's essentially a binary object, so you can store any data. Then you have Azure Files. So this is nothing but an SMB protocol based file storage. Then you have Azure Queue. So Azure Queue is something, people who have worked in MSMQ, the Microsoft managed queue, this is the same version in Azure, which is called as Azure Queue. So it's a queue store. And then we have Azure table. This is a NoSQL store for your no schema storage of structured data. So this is a specific type of storage, Azure table, where we store the data in a tabular structure, but it doesn't require any schema. It's a NoSQL based store. So you can easily deal with high volume of data. A typical example would be, let's say that you're storing a log. So you have an IoT sensor. That IoT sensor is generating log. So of course you have a structure for your log. You know that what all things will be logged, but this is a very high volume of data. So in this cases, when we need a structured data but in a very high volume, a typical SQL is not able to solve this purpose, then we go for a NoSQL store which can store structured data. Then we go for Azure table. Okay, now of course we are not just limited to this. We can provision different technology store like data lake store, HD Insight, or you can use Azure storage also. Now how does Microsoft store the data is that this again based on your SLA or the agreement with Microsoft. Microsoft will either store the data in a hard disk or they will store it in a solid state drive. So based on the plan that you have taken, of course you can understand SSD, if you store, your performance will be better, but this will be considered as a premium storage. If you go for a standard storage, they will store it in a magnetic disk or in a hard disk.